All right. Welcome, everyone, to delivering and monetizing your content with Video Center Operations on AWS. I'm Alex Zhang. I'm a product manager on AWS, and I have with me also Khwaja Shams, who's the VP of Engineering at AWS Elemental. And this session, we are going to talk a bit about the history of broadcast from traditional linear playout to the changing consumption patterns over OTT today. And specifically, we're going to talk about how you can deal with these changing consumption patterns over OTT by leveraging a combination of Elemental's software-defined video architecture and the infrastructure building blocks on AWS. So with that, I'm going to turn it over to Khwaja.
All right. Thank you, Alex. So let's take a quick detour into the history of broadcast. And television has such a fascinating history. It was not until 1900 that the term television was first coined. And that word was not the only contender for the name of television. People wanted to call it, radio vision, telephonoscope, all kinds of interesting things. But in 1900, Pirsky coined the word television at the Paris World Fair. And this wasn't a demonstration of a television by any means. At this point in time, this was just a survey of the state-of-the-art technologies like the NIPCOW discs that could be integrated together to realize the vision of presenting moving pictures from afar. And then it wasn't until about 25 years, a quarter of a century later, that the first public television was demonstrated at the Selfridge department store in London. And this is not the type of television that you think of when I say the word television. This was a mechanical television with a bunch of NIPCOW spinning discs, two of the NIPCOW spinning discs, and a very loud motor that's going around spinning and making a lot of sound so that you can see a picture. And a lot of you here care about video quality, HDR, and so forth. This day and age, the HDR, think about it this way. The human face does not have enough contrast to be able to be presentable on a TV like this. So what John Baird did in his demo at Selfridges was he took a ventriloquist dummy, put lots of bright makeup on it, and then used that to do the demonstration. And even until much later, when actors were being put on stage to present on TV, they would put blue lipsticks and very bright makeup to accentuate the different curves of the face. And in 1925, you had the mechanical television, and then it took us another 4 years, in 1929, to have the world's first electric television. And what I mean by electric television is that there were no moving parts in this. This was completely electric. And this was done by Philo Farnsworth, who used this television. The demonstration that he did was a demonstration of with a 3.5-inch picture of his wife, Emma, with her eyes closed, and they broadcasted that picture. And the reason why her eyes were closed was because to pick up her face, there was a lot of blinding lights just pointed at her, right? So she couldn't actually open her eyes, but she stood silently and steadily and tried to keep her smile on with the bright lights, and then this was broadcasted. 3.5-inch screen, all right? Just to put that into some perspective. So the 20s, 2 decades or quarter century later, were pretty profound for the age of modern television. We went from mechanical to electric TVs and so forth. And then it took us another few years. Sorry, I'm looking at the wrong screen, I think. It took us another decade to be able to make the first television network, the first public television network. And it was CBS in the United States that made that first vision. And then if you take a look at the proliferation of televisions across these decades, in 1936, there was only 200 televisions across the United States. And in those early days, people were actually quite afraid of the television. There were concerns that the television stations could actually see what's happening inside of your house. There was a person who wrote a letter to the BBC saying, "I'm afraid that this television could see through my bathroom walls," and report back to the BBC. But over time, people became familiar and comfortable with the technology, and the proliferation really began. In 1945, just a decade later, we went from 200 to 10,000 sets, and that number quickly tripled by 1948 with 35,000 sets around the country. In the 30s were also the first broadcast of a color, pictures, color broadcast. And this was done from Crystal Studios to London's Dominion Theatre. And then another decade later, in 1950, was when the first color television was released that was commercially available. And then it was another year until the first program in color was actually broadcasted over national television. And again, following that proliferation from 200 TVs in 1936, we got to a point in the 1950s where there were 6 million television sets. And a lot of them were color, and this worked out really well. TV started to become a really incredible part, an essential part of our culture. In 1950s, the Queen Elizabeth II's coronation was broadcasted on TV with people glued to these public TV sets where they could be a part of what's happening around the world. And this went even further in the 1960s when Neil Armstrong landed on the moon, right? When he said his famous words with people glued to their television, hearing him state that this is a first step for man and a giant leap for mankind. And in the 60s, along the lines, it became part of the culture to the point where if you wanted to be in the know, you kind of had to watch TV with 60 million TV sets. And then the 90s came, and this revolution kept catalyzing and kept speeding up. We went from analog to digital broadcasting. In 1997, flat screen TV started becoming a part of your daily life in your regular US households. And by 1997, about 98% of the houses in the United States actually had at least one TV. And across the United States, there was about 219 million television sets. 1936 to 219 million in 1997, just 60 years later. And it kept speeding up in the new century, in 2000s. We switched off analog in the United States completely to go all digital. There was an IP delivery revolution that was catalyzed by the advent of the iPhones and the smartphones, the iPads and tablets. And these smart TV devices that you could just plug into your old TV, like the Roku or Apple TV, that you can use to watch content at your disposal. Whatever you wanted to watch was at your disposal with very nice controls. And that wasn't it. Even gaming consoles started to serve a second purpose to allow you to watch streaming content on services like Netflix. And again, the expectation and the entitlement of the consumers just kept growing. And how we went from these mechanical televisions with these glimmery pictures to these black and white electric televisions to color televisions to HD to flat screen, and even that's not good enough yet. Because now you've got people investing very aggressively in 360-degree immersive content. Right? We're not quite there yet, but it's happening. Right? The experiences are continuously getting enriched, and it's all happening at a faster and faster pace. And this is where Elemental comes in. For those of you who don't know us, we're a broadcasting transcoding company, and if you have at heart, and if you have seen pictures, videos on your digital devices, chances are that you've at least seen a few pixels that were processed by Elemental. And let's go back to that detour of our historical context again. And one invention that I glimmered over was the VHS tape and the VCR. And this also set a brand new style of expectations from the customers. With VHS, consumers were no longer confined to whatever is being broadcasted on television at the time. They were not confined to the ad breaks to run to the bathroom or to run to the kitchen to get the next piece of snack. They could just go to Walmart or Costco or whatever it was, buy the latest released movie, bring it to their house, and command this whole new level of control over their playback. They could pause at will, they could rewind to hear back what somebody really said, they could forward through the boring pieces, and so forth. And people started using these VCRs to even record live content. So, well, you can skip over the ads. That was one big reason why I did it. But moving forward, the race is on, right? Consumer experience and expectations is going to continue changing. And it's up to the broadcasters and the content owners to continuously invest in enriching this experience. An OTT experience, what that means is some of the most basic things, like the ability to pause, rewind, start over the episode that the consumer is watching, to do catch up, to have a personal video recorder available at the consumer's disposal. Doing all that while meeting the same reliability expectations that consumers have gotten used to from broadcasters. Broadcasters have figured this out. It's very rare for you to be able to turn on your TV and see your over-the-air broadcast is not working or your cable is not working. People are expecting that same level of reliability from your OTT providers. And then last but not least, while you may be able to argue about whether consumers really want ads or not, it is hard to argue with the fact that more relevant ads can sustain the engagement of the users a lot better and for a lot longer period of time. So if you want to avoid the consumers changing the channel or moving on to a different medium by which they consume media, they can, you want to have ads that are A, relevant to the people who are watching, B, that are high quality, C, there are all kinds of things like normalizing the audio so you don't have this jarring experience where you're listening to the TV and all of a sudden the ad comes in, it's too loud or too soft. And it turns out that broadcast is still one of the most dominant ways to watch TV. And people still prefer watching their TV on their primary screen. And the reason for that is even though it's incredibly convenient to watch it on your mobile device and you have all the controls of playing and so forth, people expect the same level of controls in the big screen TV inside of their house so that they can share the experience with their friends, with their family, and watch these experiences together. Nonetheless, mobile and tablet sales and eyeballs on mobiles and video consumption on mobile and tablets continues to rise. And what cloud computing offers broadcasters is the ability to get resiliency, which means that if your Playout services is running on the cloud, you've got access to multiple availability zones. These are physically separated data centers, so that if something goes wrong, if one of the nodes fails, you can build your system to be able to automatically fail over in a seamless manner so that your consumers don't even know that a failure had occurred in your service. Or if an entire data center fails, you can seamlessly fail over to a brand new data center. Or if an entire region fails, or if the network links have issues, you can fail over to a completely different region. It offers you the flexibility. It offers you the ability to quickly compose different types of workflows and use only the types of, only pay for what you're consuming. And it gives you the ability to scale. So if you want to go from 1 channel to 50 overnight, you're able to do that. And not even overnight, you can do that in a matter of minutes. And the most important thing that this gives you is not the resilience, flexibility, or scale. It's the actual agility. When you're competing in this world where the consumer experience is constantly being enriched, there's new devices coming out, there's new standards coming out, you want to be able to turn these around as quickly as possible. And what cloud gives you is the ability to experiment, fail quickly, or keep up. So let's go back a little bit and look at how Playout services are done on-prem today. There's a few attributes of this that are quite obvious. On-prem, a lot of these Playout services, they're slow to upgrade, meaning that you're often confined to the same hardware that you had bought, and you're only confined to the capabilities of that hardware. So if a new system comes in, or if a new capability comes in, you often have to buy new hardware. And it's also expensive to scale. You not only have to go buy the hardware, you have to keep the hardware somewhere. You have to make sure you have enough rack space. You have to make sure you have enough cooling and power and so forth. There's fixed storage. If you run out of storage, even if you're using a big SAN, if you run out of storage, you still have to go out and order that storage. And all of that is coupled with a ton of SDI cabling throughout your data center. And the reason why that is let's just take a quick look at what this typical workflow looks like. You've got this massive SAN, which is often multi-tenanted. So it means that when somebody ends up running a backup job or something intense, that could actually end up having an impact on your whole system. You got that connected over to the Playout server, which is connected to the master control switch over SDI. And then you've got this automation control system that is commanding the master control system on what to do, whether to take the input from the files or take the input from the live stream And that goes over SDI to the actual transcoder and then finally goes to the broadcast TV. There's a lot of moving pieces and lots of SDI cabling across your data center. And you can improve this significantly. If you use elemental, like if you use a live controller, transcoder, you can obviate a lot of these moving components, like the Playout server and the master control switcher can completely be obviated by being built into the software inside of the live transcoder. You can have the automation control system directly command the live transcoder and then be able to choose between a live feed or a set of live feeds as well as your NAS. And it gets better in the cloud. You have the SDI cabling and the SDI interfaces completely replaced by Direct Connect, where you can have the ability to get a dedicated 1 gigabit connection or 10 gigabit or one or more 1 or 10 gigabit connections that you can use in a dedicated line to take your contribution feed directly into the cloud. You also have virtually limitless scalable storage in the form of S3, which is, again, available to you in a pay-per-use model in a highly available and durable environment. So now that flexible and scalable storage, as well as that resilient IP connection, is connected to a live transcoder. This can still be controlled by your automation control system that you may have on-prem. There's no reason, just because a live transcoder is running on the cloud doesn't mean that your on-prem automation control systems can't command it directly. And over time, what we predict is you'll see more and more of these automation control systems being available natively in the cloud as well. Once you're done with the transcoding, if you want to do packaging, you can feed this directly into Elemental Delta, which can do packaging as well as serve as an origination service to connect to your content distribution networks in the form of CloudFront, which then you can use to deliver directly to the various devices that your consumers might want to use to view your content. And the other interesting thing here is that all of these pieces are completely composable. And that's the agility and flexibility that we talked about earlier, is that you don't have to use this entire workflow. You can compose your own workflow from the various pieces. You can use a different CDN, or you can use a different packager, or you can use a different transcoder if you wanted to. And then the other piece, when it comes to doing the advertisement, you can have your ADSs command your Delta and stitch in ads in static ads in the middle of your stream and replace your SCSI-35 markers. But to transcode these ads, you can use, you can treat them just like any other VOD asset and transcode them back via using Elemental Server, which is a file-based processor. Now, this will handle your OTT requirements. But if I told you that you have to do all this while also maintaining that same traditional on-prem workflow for the primary screen, that would be pretty bad. But what you can do here is you can just go directly from Elemental Live via Direct Connect back into your data centers or to your MVPD and control and send the same broadcasted stream over to your broadcast television. So let me just go ahead and give you a quick demo of what all this means. And we've set this up, and we're doing this live, so this may or may not work. That's right. All right, so this is a demo that we have stitched together for the purposes of this presentation. What you have here is an input that's coming directly into the live transcoder and the output that is playing on a basic player in Safari. You can also watch the same player, same playout here. If I copy this, all right, so you can watch the same thing being played out here. I have the exact same stream running on my iPad here as well. So let's go ahead and see what this is composed of. So you've got Elemental Conductor Live over here. And what it's doing right now is got 4 file-based sources currently configured. There's one with cats, there's one with donuts, one with flowers, and et cetera. But these are all file-based inputs. You can also just add 1 or more live input streams as well into the same workflow. And then if you scroll down here, we choose one of these inputs, and we output 3 different bit rates. Very simple. You've got the low, medium, and high bit rate with different resolutions. And that feeds from the transcoder into elemental delta. And you can see on delta, you've got 3 streams coming in real time. And then in delta, you can have lots of different filters. For the purpose of this demo, we just have this passing through. But you can add all kinds of filters in a chain where, if you wanted to do HLS, if you wanted to do Microsoft Smooth, or if you want to just delay and so forth. And you don't have to be confined to 1 or 2 filters. You can get it pretty much as many as you want and just chain them together. So let's take a look at what kind of things you can do on your broadcast television screen with this. So I can switch the input from big cats to, oh, that's interesting, to donuts. There we go. And there's going to be a 10-second delay between what the encoder gets and what the viewer is going to see. This is just because we've got 4-second HLS segments, and the player has to play out whatever it's got in the buffer. And basically, this entire command can actually also be done via a RESTful interface. So you can have a script in any language you want to just do something as simple as, all right, now choose this particular input from what you were playing earlier. I can go to a completely different input as well. And again, 10 seconds later, this would flowers. This thing will update as well. I can add motion graphics. So now it says elemental rocks. So let's go ahead and update the subject. And here you'll see it says elemental. We were recently acquired by AWS, so let's go ahead and write that. So I can change this. And again, as you're doing this, this is the same video stream that any of your consumers, and regardless of which device they're on, would see. All right, but this is just one part of it. So if I wanted to put something live in there, I can do that as well. So I'm going to just go ahead and get the latest set of tweets that are tweeted by Elemental. And I'm just going to click Update. And you see them playing at the bottom there over here. And again, it's just simple REST commands to change the motion graphics here. If you're presenting sports, you can do squeeze backs, so you can render information here. And again, also a very simple REST command. And again, I think at this point, you're just seeing the different capabilities, but essentially, you have the flexibility to do this completely in the cloud and get all the access to the various playout controls that people are expecting to enrich your content directly available to you, regardless of whether you're doing it on-prem or on AWS. All right. With that, I will, if I can figure this out, turn that over back to Alex. Thank you.
All right. Thanks, Khwaja. So to review that previous section, building your live channel playout workflow in the cloud really allows you to keep up with the pace of OTT changes by taking advantage of a combination of Elemental software-defined architecture and the agility of AWS. We talked a bit about how you can use multi-AZ and multi-regions to architect highly resilient workflows. by having seamless failover between your different encoding, packaging, and playout stacks. We've talked about how you can scale your channels quickly as your number of end users and your number of channels grows. So doing all of this is a little expensive. Viewers are demanding new ways of watching content in time-shifted ways across multiple devices. So in order to really serve this type of content to users at scale, you need to be able to recoup some of those losses and monetize that content through ad-sponsored content. So let's talk a bit about the evolution of server-side ad insertion and how you can really take advantage of new technology and new trends that are emerging in this space. So Khwaja talked a bit about the history of broadcast. The history of advertising really began in 1941 with the first broadcast ad. And that was an ad of a Bulova time watch. It's a watch company in the United States. And the ad played for 10 seconds on a shaky camera that showed a watch overlaid on a map of the continental US. And reports say that the advertiser, Bulova, paid $10, $9 to $10 for that advertisement. Now, broadcast TV has obviously evolved a long way since then. For example, in the 2015 season of The Walking Dead, reports say that for a show that reached 15 to 20 million end users, a TV ad spot cost about $400,000. Despite all the growth in broadcast advertising, 2016 is really going to be the first year that digital advertising overtakes broadcast in the United States. Digital advertising spend is going to reach $72 billion versus $71 billion in the US. Now, digital includes other channels such as mobile and paid search and banner ads in addition to video, but video is driving a lot of this growth. So why is video advertising growing so quickly on OTT platforms? The reason why is that with OTT, you no longer have to rely on age, gender proxies set by Nielsen gross rating points to purchase TV ad spots in advance, where you end up targeting really a small subset of your end users. With OTT, you can take advantage of first-party publisher data in conjunction with third-party data from data management platforms and sort of combine that behavioral and contextual data to target the end users you want to target. You have more robust viewability metrics and more robust measurement of what your users are actually doing to engage with your content. And finally, you can serve different types of ad content, not just traditional linear ads, but also nonlinear interactive ads, as well as companion creatives. But OTT advertising is still in its infancy. There's still a scarcity of premium video inventory, as you may know, on the internet. And as a result, the range in CPM for video inventory is very large. Someone like a provider like Hulu can command $35 on average per 1,000 impressions, whereas non-premium channels like YouTube command as low as $2. So as a premium provider of video content, what you can do to take advantage of really this broad adoption of OTT advertising is by starting with client-side ad insertion, which is really the traditional method of doing ad insertion on the internet today. So a typical client-side ad insertion workflow starts at the encoder. Here you see Elemental Live on the bottom left, where Elemental Live could be ingesting a stream already delineated with ad markers, or Elemental Live, you could issue API commands against the Elemental Live encoder to insert SCTD202 markers frame accurately on the program and ad boundary. Now, within the SCTD202 marker, you can obviously encapsulate other information that may be important to your use case, like ad ID, program schedule, and other indicators. Now, Elemental Delta is our just-in-time packager and origination service, which must work closely with Elemental Live in order to package that video content and that ad content frame accurately into a stream that OTT devices can consume. Now, this could be delivered over HLS, Dash, Smooth, or HDS. Now, in order for all those SCTD202 attributes to be visible to a downstream client to act on, Delta would have to surface those SCTD202 attributes within the manifest, in the case of HLS, in the HLS manifest. So further down to the right, you can see clients connecting to Elemental Delta. And when those clients encounter those SCSI-35 markers within the manifest, it will then call out to an ad server based on the ad tag URL provided by that ad server and carry with it the identifying information required for that ad server to perform decisions on. These could be encapsulated within the headers, query strings, and third-party cookies, and so on. The ad server, of course, then returns the ad asset through either an inline XML within VAST, or it could be a third-party ad, in which case the client would have to be redirected to external ad source. Now, all this could get complicated with other types of creatives like vPaid and so on, but the idea remains the same, that client-side ad insertion really gives you a lot of interactivity and targeting available on OTT. But client-side ad insertion, of course, comes with its downsides, which many people are familiar with. The first is obviously poor user experience due to all the middlemen and sort of the different intermediary services that a client has to contact. These include publisher ad servers, marketing agencies ad servers, demand-side platforms, supply-side platforms, and any programmatic sources that may come through ad exchanges. All of these round trips to retrieve an actual ad results in poor network latency and poor user experience on the client as it buffers. So as a result of this buffering issue, client-side ad insertion really isn't feasible in live playback scenario with broadcast quality. And since publishers don't really control the ad creatives in many cases, especially in programmatic scenarios, there's a lot of inconsistencies in the codecs, bit rates, and audio normalization levels returned to the client for ads rendered on the client. And this obviously creates a poor user experience, much in line with the high latency experience by clients. Developing for client-side ad insertion is hard, with having to build ad libraries across iOS, Android, web, and all of your OTT platforms, many of which, especially for connected TVs, don't even allow client-side libraries to load. And finally, people are familiar with the high ad block rate you see on desktop and mobile web, which is highly correlated with the poor user experience, your end users experience from client-side ad insertion, where we learned that over 64% of people end up installing ad blockers because of the high latency they see and the buffering that they see when playing back a client-side ad inserted stream. So this brings us to really the next phase of OTT advertising, which is server-side ad insertion. So server-side ad insertion really is able to leverage the personalization powers of client-side ad insertion, while at the same time maintaining that broadcast quality and hopefully improving ad fill rates by circumventing ad blockers. So server-side ad insertion, we push all that logic of stitching together video content with ad content to the server, and we, at the same time, the server is responsible for coordinating all those callbacks to ad servers and other intermediaries. At the same time, a server-side ad insertion service should employ just-in-time transcoding or on-the-fly transcoding for ad creatives in order to normalize those ad creatives to the same specs as your video content. But really, in order to build a effective server-side ad insertion platform, you need a highly scalable service running it. And this is really because you can no longer rely on distributed clients to make all those callbacks, to ad servers. The service that you're running is responsible for that. So you really need to be able to scale effectively. And this brings me to segue into what Uyala has done, which is built a server-side ad insertion service using a combination of Elemental services as well as AWS infrastructure building blocks. So Uyala, as many people may know, is an online video platform that offers end-to-end solutions in managing, publishing, and monetizing content for video publishers. So the Uyala and AWS Elemental solution involves a few components. Starting from the client, which we see in that diagram on the far bottom right, the manifest request from the client is no longer going to your content origin. It's in this case, elemental delta. Instead, the manifest request from the client is going to a highly scalable service called the ads proxy, in this case, and which is fronted by a fleet of load balancers that distribute traffic accordingly to different ads proxy servers. The ads proxy is responsible for personalizing manifests and returning those personalized manifests to the client. We have to maintain a one-to-one mapping of a personalized manifest to each client because each client is getting a unique combination of ads in a unique ad pod in a unique configuration. As a result, there's nothing really cacheable for the manifest on the CDN. So for CDN settings, you have to set a 0 TTL. So it's a complete pass-through on the CDN to your ads proxy service. At the same time, the ads proxy service fetches the parent manifest from elemental delta. So the parent manifest will have SCUDdy35 markers delineating where the ad avail opportunity is. When the ads proxy receives that template manifest, that parent manifest, it sort of pulls elemental delta every few seconds to see if there's an updated version of that manifest, which is important for a live playback scenario. So the ads proxy then takes, as part of the manifest request from the client, it takes the header information from the client, typical user agents and so on, as well as custom query strings that are passed as key value pairs to the ads proxy, which are then passed on to the ads server, which in this case is Uyala Pulse, in typical VAST request. The ads server then responds back to the ads proxy with a pointer to what ad IDs are available. Those ad IDs are only available when the actual ad is transcoded, which is done by the second service here you see called Ad CMS under Uyala Live. Now, the Ad CMS is running on Docker containers on Amazon Elastic Container Service, and it's a transcoding service that periodically pulls Uyala Pulse for new ad creatives and transcodes them, pre-transcodes them every few minutes. And it tells Uyala Pulse which creatives are available, which can then be returned as part of the VAST response to the ads proxy. The ads proxy then stitches together references to both the video content and the ad content and presents that as a personalized manifest back to the client. Now, as I said before that the personalized manifest is not cacheable, but video content fragments and ad content fragments themselves should, of course, be cacheable and should have long TTL settings on your CDN. So really, this service and sort of server-side ad insertion in general results in a better viewer experience. It's really the inverse of what you saw with client-side ad insertion. It streamlines delivery to many devices because you can make your changes on your server-side ad insertion service once and not have to continuously update and maintain different client-side ad libraries for the different devices you want to stream content to. You can target more devices. So devices like Roku and, or connected TVs rather, which can't load thick client-side libraries would be able to still stream content and receive content that's server-side ad stitched. But ultimately, we think that the story should be a hybrid story between client-side ad insertion or some client-side capabilities in conjunction with server-side ad insertion. So OTT allows you to do things like measure viewability. And viewability is, of course, a very important metric because it's important to not just serve ads, but also ensure that your viewers have viewed those ads. And viewability is defined as 50% of ad pixels present for at least 2 seconds on the screen. And in order to do viewability, you need to be able to load client-side libraries that can do that from third-party providers. So you need your server-side ad insertion service to work closely with that third-party provider to at least tell that third-party provider when ad markers are coming up on the client. So in the Uyala case, on the earlier diagram, Uyala has these client libraries on their player that surfaces to the player that an ad break is has entered by using ID3 tags that were inserted during the encoding process for ads. So we'll now quickly show you a demo of the Uyala ad insertion process. It's pretty straightforward. It's a really simple demo that shows two screens here with live content from stars. You can see there's two users, two different users on these two different screens. There's Alice and Kathy. They have different profiles, different attributes that would be sent as part of the VAST request. Whoops.
There you go. Yeah, there you go.
So let's look at the Elemental Conductor Live interface, where you have the input source content arriving over RTP to the Elemental Live encoder. And Elemental Live encoder has the add avail blanking feature, which really is a splice insert command for SCTD35. Typically, your input stream would have SCTD35 markers already within the stream, but in this case, we're sort of overriding. There's no SCTD35 markers already in the input stream, so we have to sort of have this big red button functionality to manually insert ad opportunities. So let's just quickly insert a 30-second opportunity. So you'll see the input source has blanked out. And because the player keeps 3-segment buffer, we'll probably see the ads show up in about 30 seconds or so. The input stream from Elemental Live is going to, meanwhile, to Elemental Delta, which over HLS. Elemental Delta then passes through that HLS and surfaces the SCTD35 within the manifest itself, which clients can then read and act on. But in the case of course, in the case of server-side ad insertion, those ad markers could be dropped off so that clients don't get any hints that an ad avail opportunity is present. So here you can see ads have played for both clients. They're different ads. One on the left is sports, the one on the right is a perfume ad. The ad is two 15-second ad avails within the ad pod. So now we've cut back to the main content. All right, that's the demo. So today we've talked about how broadcast has really evolved from the early 1900s, traditional linear playout, to changing patterns over OTT today. If we look at 2016 and beyond, we think that the cloud, in conjunction with software-defined video architecture, really allows you to quickly and with agility and with high resiliency and availability produce new services and features for your customers without having to provision new hardware, without having to invest in a lot of CapEx in order to bring those services and features to bear. Whether those services be Playout in the cloud, client-side ad insertion, server-side ad insertion, or in the future, even personalized playout schedules on a per-user basis based on content blackout, user preferences, and recommendation engines. So with that, that concludes our presentation. Thank you for attending. I'm Alex, this is Quadra, and we appreciate your time.